Frequency-dependent selection is the term given to an evolutionary process where the fitness of a phenotype is dependent on its frequency relative to other phenotypes in a given population. What does this mean? Well, let's break it down piece by piece. This is frequency-dependent selection in plain English. First, it's an evolutionary process. This means that gradually over time, species change or evolve. The next component is fitness. High fitness does not necessarily refer to the strongest individuals. Rather, it refers to those with high reproductive success. And the more offspring you have, the more fit you are. The definition also includes phenotype. Phenotype is the way genes are expressed in a species, often in appearance. There can be several phenotypes for a particular trait, such as hair color. Now that we broke it down, let's put it all back together with an example that actually occurs in nature. The African cichlid fish exhibits frequency-dependent selection. This fish actually makes its living by snatching the scales off of the sides of other fish. Some of these fish have jaws twisted to the left and some to the right. So, which of these phenotypes is more fit? Well, this all depends on the prey. Let's say we start off with a large population of right-jawed fish and a small of left-jawed fish. Because of the twist in the jaw, the left-jawed fish will always attack the prey from the right side, and the right-jawed fish will always attack the prey from the left side. Since there's a large number of the right-jawed fish right now, this causes the prey to be on the lookout for its left side. Now the prey fish are aware of the right-jawed cichlids and flee. This gives an advantage to the fish that are attacking from the other side with the left jaws. So now the left-jawed fish can get food more easily than the other fish, and those other fish start dying out because obtaining food is more difficult. The reproductive success increases of the left-jawed fish, and they are more fit. For a while, the left-jawed fish remain the most fit of the population, but this soon changes. As they notice more attacks, the prey fish start looking over their other side. Now the prey expects attacks from its right side and can flee when the left-jawed approach, but when the right-jawed approach, they aren't expecting it, so the right-jawed get the food. So now the tables have turned. The right-jawed become more fit, and the left-jawed start dying out. This cycle repeats itself, with an increase in one phenotype actually causing a decrease in its own reproductive success. So, since the frequency of one phenotype determines the fitness of the other phenotype, thus changing the population's overall genetic makeup, this is a perfect example of frequency-dependent selection.